Okay, so we looked at how to factorize quadratics, particularly quadratic trinomials. So those were quadratics with three terms in the expression. But now we're going to look at how to factorize the difference of two squares. So the reason these are called the difference of two squares is because one, there will always be a minus in between them, and then squares because they will have a whole square root, as in there will be a number, the same number that will multiply by itself to give us each term. So for example, in this one here, a squared minus b squared, we can rewrite a squared as a times a, and then keep our minus, and then we can rewrite b squared as b times b. Okay, and we can throw that in brackets. So both our a's are positive, so we can keep them like that. And then one of our b's has to be negative and the other has to be positive for us to get a minus b squared. So we make one of the brackets have a plus sign and the other have a minus sign. And then we throw our term that will multiply by itself to give us b squared there. So that is how we factorize the difference of two squares. You have to look at this and you think, okay, what multiplied by itself is going to give me a squared? Well, that's a. And what multiplied by itself is going to give me b squared? And that's b. And then we put them in brackets and we put a plus and a minus sign each. And we can verify that this answer is correct by multiplying this out. So I have a times a minus b plus b times a minus b. So that's going to give me a squared. A times minus b is minus ab. A times plus b is plus ab. And b times minus b, well, that's going to give me a minus overall because it's a plus times a minus. And then b by b is going to give me b squared. And you'll notice that these middle terms in here, so the minus ab and the plus ab, well, they're like terms, so we can add them together, but it's a minus ab and a plus ab, so they're going to cancel with each other, and I'm left with a squared minus b squared, which is what I started off with. So that means that our factorization here of the difference of these two squares is correct. Let's have a look at the next one. So we have 4x squared minus y squared. So 4x squared, what multiplied by itself is going to give me 4x squared? Well, that's going to be 2x times 2x. Because 2 by 2 will give me the 4 and x by x will give me the x squared. And then what multiplied by itself is going to give me the y squared? That's going to be y times y. Okay, and then we're going to open our two brackets again because we want to factorize this into two separate brackets. Both of my two x's are positive, so I put a 2x in one and a 2x in the other. And then I have to put a plus and a minus in, okay, and then I have a y in one and a y in the other. The reason this plus and minus is in here, two reasons really. You need this to be a minus y squared. So you need to have a positive times a negative, right? So that plus y times that minus y is going to give us that y squared. And we know when we're multiplying our brackets, we saw it in the previous one, that we always do the first term times the second bracket and the second term times the second bracket. So what's going to happen is we'll get a 2x times a minus y, which will give us a minus 2xy, and then we'll get a plus y times a 2x, which is a plus 2xy. So those middle terms will cancel us out and they'll only leave us with 2x times 2x and y times minus y. And we saw that here, so our middle terms cancelled out here because one of these is plus and one of these is minus. All right. Let's have a look at the next one. So we have 9c squared minus 16d squared. So 9c squared, well, if I multiply 3c by 3c, that will give me 9c squared because 3 times 3 is going to give me a 9, and c times c is going to give me a c squared. Minus 4d times 4d. Because again, a 4 by a 4 is going to give me a 16, and d by d is going to give me a d squared. And then we're going to throw these into two brackets. So I have my 3c, both my 3c's are positive, so they go at the start, they're my first term in each bracket. And then I have a plus and a minus, so that'll get rid of my middle terms. And then I'm left with 4d and 4d. Alright, next one. 144x squared minus 100z squared. So the square root of 144, so the number that's going to multiply by itself to give me 144 is 12. And then I'm going to need an x to get me that x squared. Minus 10z times 10z. Again, 10 by 10 is going to give me the 100, and z by z is going to give me the z squared. Then we open up two brackets. Okay, my 12x's are positive again, so we're just following the same method. And then my 10s, or then I have to have my plus and my minus. So that'll give me a minus term at the end, which is what I want. And it'll cancel out my middle terms. And then I put in a 10z and a 10z because that'll give me the 100z squared. All right, and just for practice, we can verify this one. So if I multiply out these brackets, I should get this expression that I originally started off with. So this is equal to 12x times 12x minus 10z plus 10z times 12x minus 10z. Okay, so that's my first term times my second bracket plus my second term times my second bracket. 12x times 12x is 144x squared. 12x times minus 10z, so the plus times a minus, it's going to leave me with a minus. 12 times 10 is 120. And then I've got an x and a z. And that's the simplest way we can write this, just by putting the numbers beside each other. So that shows me that 120 is multiplied by x and z. And then I've got plus 10z times 12x, so that's going to give me 120xz again. And then I've got 10z times minus 10z, so a plus by a minus will leave me with a minus. And 10z times 10z, well, that's going to leave me with 100z squared. Again, my two middle terms are going to add together because they're like terms, and they're going to cancel, so they're going to leave me with 0. So all I'm left with is 144x squared minus 100z squared, which is what I originally started off with. So we know that our factorization here is correct. Okay, 25m squared. So 5m by 5m will give me the 25m squared minus 7n times 7n. That will give me the 49n squared. And then again, I open up my two brackets and then I say, okay, my 5m's are both positive. And then one of my 7n's is going to be negative, because a plus by a minus will give me that minus, and then 7n by 7n will give me the 49n squared. And again, my middle terms will cancel out as we saw before. Okay, this next one is a wee bit trickier. So there is no number that will multiply, well, there is a number, but it's not a natural number that will multiply by itself to give me 125. So what I can do first is I can see that 5 will divide into both of these. So I can factorize this by taking the 5 out. So 5 times a squared will give me 5a squared. And then minus, so 5 into 125 goes 25 times. And then I need the b squared. Okay, so that's that factorized, but not with the difference of two squares method. But if you look at this now inside this bracket here, this a squared minus 25 squared, that's b squared. That's the difference of two squares. So we can factorize this further and we can say, okay, we'll keep our 5 there, but we'll multiply it by, okay, what will multiply by itself to give me a? Well, that's a. And then what will multiply by itself to give me minus 25b squared? So we're going to need a plus 5b and a minus 5b. And then when we multiply this all out, that will give us back 5a squared minus 125b squared.